The sun beat down mercilessly on the dusty streets of Ouagadougou as Colonel Mamadou Traoré walked through the military workshop. His boots crunched against the sandy ground while he observed the mechanics working on various vehicles. The year was 2018, and Burkina Faso was facing one of its most challenging periods in recent history. Terrorist attacks had become frighteningly common, with armed groups crossing borders and targeting civilians, military bases, and government facilities. Colonel Traoré had been thinking about this problem for months. Every time he received reports of another attack, another convoy ambushed, another outpost overrun, the same thought crossed his mind. They needed better protection for their soldiers. The current fleet of vehicles was outdated and offered little defense against improvised explosive devices and heavy weaponry used by insurgents. That morning, he had received devastating news. A patrol unit near the border with Mali had been attacked by militants. 3 soldiers had lost their lives and 2 others were critically wounded. Their vehicle, an old truck with minimal armor plating, had been completely destroyed by a roadside bomb. As Colonel Traoré read the report, his hands trembled with a mixture of anger and determination. The problem was not just about having armored vehicles. Burkina Faso, like many African nations, relied heavily on imported military equipment. These purchases were expensive, often taking years to negotiate and deliver. By the time the equipment arrived, the security situation had usually changed and the specifications were no longer suitable for current threats. Moreover, maintenance and spare parts for foreign-made vehicles were another constant headache. Colonel Traoré had studied military engineering before joining the armed forces. He understood the technical aspects of vehicle design and armor protection. As he stood in the workshop that day watching his mechanics repair yet another broken imported truck, an idea began to form in his mind. What if they could build their own armored vehicles? What if Burkina Faso could become self-sufficient in producing military equipment tailored specifically to their needs and environment? The idea seemed almost impossible at first. Burkina Faso was not known for heavy manufacturing or advanced engineering capabilities. The country's economy was primarily based on agriculture and mining. However, Colonel Traoré had noticed something during his years of service. The local mechanics and technicians were incredibly resourceful. They could repair almost anything with limited tools and spare parts. They understood the harsh conditions of the Sahel region better than any foreign engineer. He began discussing his idea with Major Ibrahim Ouedraogo, his most trusted colleague and the head of the technical division. Major Ouedraogo was skeptical at first. Building armored vehicles required specialized knowledge, advanced materials, and sophisticated manufacturing equipment. However, as they talked more about the concept, he became increasingly interested in the challenge. The 2 officers spent several evenings after duty hours sketching ideas and discussing possibilities. They researched armored vehicle designs from around the world, studying what made them effective in different environments. They paid particular attention to vehicles used in similar climates and terrains, noting how successful designs balanced protection, mobility, and cost-effectiveness. Their research revealed that many successful armored vehicles were actually quite simple in their basic design. The complexity came from the electronics, weapon systems, and specialized armor materials. However, the fundamental structure, a reinforced chassis, protected crew compartment, and reliable engine, was within the realm of possibility for local manufacturing. Colonel Traoré decided to present his proposal to the military leadership. He knew it would be a difficult sell. Military procurement traditionally favored established foreign manufacturers with proven track records. The idea of developing a completely new vehicle locally would face significant resistance from both military bureaucrats and politicians who preferred the prestige of purchasing from well-known international companies. He spent weeks preparing his presentation, gathering technical data, cost estimates, and timeline projections. He also researched successful examples of local military production in other developing countries. South Africa's military industry during the apartheid era had produced highly effective armored vehicles specifically designed for African conditions. Brazil had developed its own armored personnel carriers that were exported worldwide. These examples proved that it was possible for developing nations to create world-class military equipment. The presentation day arrived in September 2018. Colonel Traoré stood before a panel of senior officers and defense ministry officials in a sterile, Conference room at military headquarters. The air conditioning struggled against the heat outside, and the atmosphere inside was tense. He began by presenting the security challenges facing Burkina Faso, using detailed maps and casualty statistics to illustrate the growing threat from terrorist groups. He then showed photographs of destroyed vehicles and wounded soldiers, making the human cost of inadequate protection brutally clear. Several officers in the room shifted uncomfortably in their seats as they recognized locations, and perhaps even knew some of the victims personally. The presentation was not just about military strategy. It was about protecting the lives of their soldiers and the future of their nation. When Colonel Traoré revealed his proposal to develop a locally manufactured armored vehicle, the room fell silent. Some officers exchanged skeptical glances while others leaned forward with interest. He presented his technical research, cost analysis, and development timeline. The project would require significant initial investment, but would ultimately save money while providing vehicles perfectly suited to local conditions. General Ousmane Sawadogo, the Chief of Defense Staff, asked the first question. Colonel Traoré, this is an ambitious proposal. Do you truly believe our country has the technical capability to produce military-grade armored vehicles? The question hung in the air as everyone waited for the response that would determine the fate of the project. Colonel Traoré looked directly at the general and replied with conviction, Sir, our mechanics keep decades-old equipment running in conditions that would challenge the best foreign-made vehicles. Our engineers have solved countless problems with creativity and determination. What we lack is not skill or intelligence, but the opportunity to apply our capabilities to something truly important. This project would not just give us better vehicles, it would build our national capacity and pride. The room buzzed with quiet conversations as officers discussed the proposal among themselves. Some were intrigued by the potential benefits while others worried about the risks of such an unconventional approach. The meeting concluded without a definitive decision, but Colonel Traoré sensed that he had planted a seed of possibility in their minds. 3 weeks passed after Colonel Traoré's presentation, before he received any official response. During this time, he continued his regular duties while quietly gathering more technical information and building support among younger officers who were excited about the possibility of indigenous military production. The security situation continued to deteriorate, with several more attacks reported along the northern borders. On a humid October morning, Colonel Traoré was summoned to General Sawadogo's office. The general's aide escorted him through the corridors of military headquarters, past portraits of former military leaders and maps showing current deployment zones. When he entered the spacious office, he found not only General Sawadogo, but also Defense Minister Claude Wende and Colonel Yakuba Ouattara from the Ministry of Defense Procurement Division. General Sawadogo gestured for him to sit down and began speaking in his characteristic direct manner. Colonel Traoré, we have discussed your proposal extensively. The concept is intriguing, but we need to understand the practical implications better. The minister has asked me to authorize a preliminary feasibility study. You will have 3 months and a small budget to prove that this project is not just a dream, but a realistic possibility. The defense minister leaned forward and added, Colonel, this is not just about building a vehicle. If we proceed with this project, it will be scrutinized by Parliament, the media, and our international partners. We cannot afford to fail publicly. The study must be thorough and honest about both possibilities and limitations. Colonel Traoré felt his heart racing with excitement and anxiety. This was the opportunity he had hoped for, but the pressure was enormous. Thank you, sir. I will not disappoint you. What resources will be available for the study? Colonel Ouattara opened a folder and began reading from a document. You will receive 50 million CFA francs for the initial study. This includes costs for technical consultants, materials for prototype components, and travel expenses for research purposes. You may also recruit up to 5 additional personnel for your team, preferably with engineering or technical backgrounds. The amount seemed modest for such an ambitious project, but Colonel Traoré knew it was a significant allocation for a preliminary study. He would need to be extremely careful with resource management and focus on the most critical aspects of feasibility analysis. Over the following days, Colonel Traoré assembled his research team. Major Ouedraogo remained as his deputy and technical coordinator. He also recruited Captain Salif Kabore, a mechanical engineer who had recently returned from training in France, Lieutenant Aminata Sawadogo, who had specialized in materials science, and Sergeant Chief Burema Compaoré, the most experienced mechanic in the entire military fleet. The team's first task was to define the specific requirements for their armored vehicle. They spent hours analyzing attack patterns, studying the types of threats faced by Burkina Faso forces, and examining the performance of existing vehicles in similar environments. The vehicle would need to protect against small arms fire, improvised explosive devices, and rocket-propelled grenades while remaining mobile in sandy and rocky terrain. They decided to focus on creating an armored personnel carrier that could transport 8 soldiers plus a crew of 2. The vehicle should have all-wheel drive capability, air conditioning for the harsh climate, and communication equipment for coordination with other units. Most importantly, it should be maintainable using locally available skills and parts. Captain Cabaret suggested visiting successful armored vehicle manufacturers in other countries to understand production processes and design principles. The team planned trips to South Africa and Brazil, where they could study military manufacturing facilities and speak with engineers who had experience in developing vehicles for challenging environments. The South Africa trip proved to be particularly enlightening. The team visited the facilities of Denel Vehicle Systems near Pretoria, where they observed the production of the Caspier armored personnel carrier. The South African engineers were surprisingly open about sharing their experiences, recognizing the challenges faced by African militaries in dealing with asymmetric warfare threats. During their visit, they learned about the importance of mine-resistant design features, including V-shaped hulls that deflected explosive forces away from the crew compartment. They also discovered that many sophisticated features of modern armored vehicles were not essential for effectiveness. Simple, robust design often outperformed complex systems in harsh operating conditions. The Brazilian visit to Iveco's military vehicle plant provided different insights. The Brazilian engineers emphasized the importance of using commercial automotive components wherever possible to reduce costs and simplify maintenance. Their Guarani armored vehicle successfully combined military protection requirements with civilian truck reliability and affordability, returning to Ouagadougou with notebooks full of technical details and dozens of photographs. The team began serious design work. They set up their temporary workshop in a section of the main military garage, where they had access to basic machining equipment and welding facilities. Lieutenant Sawadogo focused on researching armor materials that could be sourced locally or imported at reasonable cost. Traditional steel armor was heavy and expensive, but newer composite materials offered better protection with less weight. She discovered that some effective armor solutions used layers of different materials, including ceramics and specialized fabrics that could potentially be manufactured locally. Sergeant Chief Compaoré proved invaluable in translating theoretical designs into practical manufacturing processes. His decades of experience repairing and modifying military vehicles gave him an intuitive understanding of what would work in real-world conditions. He suggested using chassis components from heavy commercial trucks as the foundation, which would provide reliability while allowing for local maintenance expertise. The team faced their first major technical challenge when trying to design the hull shape. The V-shaped mine-resistant hull that worked so well in South African vehicles was extremely difficult to manufacture without specialized equipment. After several weeks of experimentation, Captain Kabore developed a simplified angular design that provided significant blast protection while being achievable with available welding and fabrication capabilities. By December 2018, they had completed detailed technical drawings and built several scale models to test different design concepts. They also prepared cost estimates based on their research and conversations with local suppliers. The preliminary numbers were encouraging. Their vehicle could potentially be produced for about 60% of the cost of equivalent imported vehicles, while offering better suitability for local conditions. However, challenges remained enormous. Manufacturing would require significant investment in specialized equipment and training. Quality control systems would need to be established to ensure military-grade reliability. Most critically, they would need to prove that their design actually worked by building and testing a full-scale prototype. As the 3-month deadline approached, Colonel Traoré compiled their findings into a comprehensive report. The document included technical specifications, cost analysis, manufacturing requirements, and a realistic timeline for prototype development. He was confident in their research but nervous about the next phase of evaluation. The final presentation was scheduled for early January 2019, and the stakes had never been higher for the future of Burkina Faso's military self-sufficiency. The hull construction phase began in earnest during April 2019 and immediately presented challenges that tested the team's resolve and ingenuity. The angular armor plates required precise cutting and shaping, work that pushed their equipment to its limits. Each piece had to fit perfectly with adjacent plates to ensure structural integrity and eliminate weak points that could be exploited by enemy fire. Captain Kabore spent countless hours refining welding procedures to achieve the strength and quality required for military applications. Standard commercial welding techniques were insufficient for the thick armor plates and high-stress joints. The team had to develop new methods and train their workers to execute welds that would hold under combat conditions. Lieutenant Sawadogo focused on testing armor materials and configurations. Using a makeshift ballistic testing range set up behind their workshop, she fired various weapons at sample armor panels to evaluate their protective capabilities. The tests were conducted with scientific precision, measuring penetration depths, impact patterns, and structural damage from different angles and distances. The results were initially disappointing. Their first armor configuration provided adequate protection against small arms fire, but failed catastrophically when tested against rocket-propelled grenades and heavy machine gun rounds. The team realized they needed to completely redesign their armor system, incorporating lessons learned from the testing process. This setback occurred just as external pressure was mounting. Several newspaper articles had criticized the project as wasteful spending during a time of economic hardship. Politicians who had initially supported the initiative began expressing doubts about its feasibility and cost-effectiveness. Colonel Traoré found himself defending the project in meetings with skeptical superiors who questioned whether the prototype could ever meet military requirements. The breakthrough came from an unexpected source. Dr. Rasmane Ouedraogo, a material science professor at the University of Ouagadougou, had read about the project and contacted Lieutenant Sawadogo with suggestions for improving armor effectiveness. His research into composite materials had identified locally available materials that could be combined with steel to create superior protection at lower weight and cost. Dr. Ouedraogo's approach involved using layers of different materials, each designed to counter specific types of threats. Ceramic tiles would shatter incoming projectiles, while flexible backing materials would absorb and distribute impact energy. The system was more complex to manufacture, but offered dramatically improved protection compared to simple steel plates. Implementing the new armor system required additional equipment and expertise. The team arranged for Dr. Ouedraogo to join the project as a technical consultant, bringing with him several graduate students who contributed research support and fresh perspectives on manufacturing processes. By June 2019, the hull construction was progressing steadily using the improved armor design. The vehicle's distinctive angular appearance was taking shape, with each armor panel carefully positioned and secured. The work was slow and meticulous, as any mistake could compromise the entire structure's integrity. Meanwhile, Sergeant Chief Compaoré was working on the vehicle's mechanical systems. The engine installation required custom mounting brackets and cooling system modifications to accommodate the additional weight and reduced airflow around the armored hull. The transmission and drivetrain also needed reinforcement to handle the increased load while maintaining reliability. The electrical systems presented another layer of complexity. Military vehicles required sophisticated communication equipment, navigation systems, and fire control electronics. These components had to be integrated with the basic automotive electrical system while being protected from electromagnetic interference and battle damage. Major Ouedraogo coordinated the installation of weapons mounts and sighting systems. The LX70 would be equipped with a remotely operated machine gun turret that could be controlled from inside the protected crew compartment. This system required precise mechanical engineering and electronic controls that pushed the team's capabilities to new limits. As summer progressed, the prototype began to look increasingly like a real military vehicle. The hull was complete. The mechanical systems were installed and functioning, and initial electrical testing was underway. However, many critical systems still needed final integration and testing before the vehicle could be considered ready for evaluation. The team faced a significant challenge when they discovered compatibility problems between different electronic systems. The communication radio interfered with the fire control computer, while the navigation system caused erratic behavior in the engine management electronics. Resolving these issues required extensive troubleshooting and custom shielding solutions. Colonel Traoré was acutely aware that their 8-month deadline was approaching rapidly. The prototype needed to be completed and undergo preliminary testing before the formal evaluation process could begin. Any delays would provide ammunition for critics, who argued that the project was unrealistic and poorly managed. The pressure intensified in July when Defense Minister Wende announced that foreign military observers from France and the United States would participate in the prototype evaluation. These experts would assess the vehicle's capabilities against international standards and provide independent verification of the team's claims about performance and protection levels. The announcement created both excitement and anxiety within the team. International recognition would validate their work and potentially open doors for future collaboration or export opportunities. However, it also meant that any flaws or shortcomings would be exposed to expert scrutiny and possibly international embarrassment. To prepare for the evaluation, the team developed a comprehensive testing program that would demonstrate all aspects of the vehicle's performance. Mobility tests would show the LX70's ability to operate in various terrain conditions typical of Burkina Faso's environment. Protection tests would verify armor effectiveness against realistic threat scenarios. Reliability testing would demonstrate the vehicle's ability to operate for extended periods without mechanical failure. By August 2019, the prototype was mechanically complete and ready for initial testing. The vehicle's appearance was striking, clearly military in nature but distinctly different from imported designs. Its angular armor panels and practical layout reflected the team's focus on functionality and manufacturability over aesthetic considerations. The first test drive was scheduled for early morning to avoid public attention. Colonel Traoré climbed into the driver's seat while Major Ouedraogo occupied the commander's position. As the diesel engine rumbled to life and the vehicle moved forward for the first time under its own power, both men felt a profound sense of accomplishment mixed with nervous anticipation. The initial test drive revealed both successes and areas needing improvement. The vehicle's mobility was excellent, easily handling rough terrain and steep grades. The armor provided a sense of security and protection that was immediately apparent to the occupants. However, the air conditioning system was inadequate for the interior heat generated by electronics and engine proximity, and several minor mechanical adjustments were needed. Over the following weeks, the team addressed these issues while conducting increasingly demanding tests. They drove the prototype through sandstorms, over rocky terrain, and in extreme heat to verify its performance under realistic operational conditions. Each test provided data that was carefully recorded and analyzed to identify any potential problems before the formal evaluation. As September approached, Colonel Traoré felt cautiously optimistic about their chances of success. The prototype had exceeded many of their initial expectations and demonstrated capabilities that were genuinely impressive for a locally manufactured vehicle. However, he also knew that the most challenging phase was yet to come. The presentation hall was packed on January 15, 2019. Word about the armored vehicle project had spread throughout military circles, creating considerable interest and skepticism in equal measure. Colonel Traoré stood before an audience that included not only military leadership, but also representatives from the Ministry of Finance, several members of Parliament, and even a few journalists who had somehow learned about the meeting. Colonel Traoré began his presentation by displaying a detailed scale model of their proposed vehicle design. The model showed a robust, angular vehicle with obvious military characteristics, but a distinctly practical appearance. Unlike the sleek lines of expensive European armored vehicles, their design emphasized functionality and manufacturability over aesthetic appeal. "Distinguished guests," he began, "after 3 months of intensive research and analysis, I am pleased to present our findings on the feasibility of local armored vehicle production. Our proposed vehicle, which we have designated the LX70, represents a realistic approach to meeting our military's protection needs while building national manufacturing capability. The LX70 designation had been chosen carefully. The L stood for local, emphasizing the indigenous nature of the project. The X represented the experimental and innovative aspects of the design. The 70 indicated the year of Burkina Faso's independence, 1960, plus the 7 decades that had passed, symbolizing the country's maturity and readiness for technological advancement. Major Ouedraogo presented the technical specifications, explaining how the vehicle's design balanced protection, mobility, and manufacturability. The hull would be constructed from locally welded steel plates with additional composite armor panels. The engine would be a commercial diesel unit already used in heavy trucks throughout West Africa, ensuring easy maintenance and parts availability. Captain Kabore discussed the manufacturing requirements, presenting detailed cost estimates and production timelines. The initial setup costs were substantial, requiring approximately 2.5 billion CFA francs for equipment and facility preparation. However, once production began, each vehicle would cost significantly less than imported alternatives, while providing superior support for local industry. Lieutenant Sawadogo's presentation on materials and testing was particularly compelling. She had identified several local suppliers who could provide steel and other basic materials. More importantly, she had developed relationships with regional universities whose materials science departments could support ongoing research and quality control. First, the most powerful moment came when Sergeant Chief Compaoré spoke about the practical aspects of maintenance and operation. His weathered hands gestured toward the model as he explained in simple, direct language how the vehicle's design would make life easier for soldiers and mechanics in the field. "This is not just a machine," he said. "This is a tool designed by people who understand our environment and our needs." Defense Minister Wende asked the first question. "Colonel Traoré, this presentation is impressive, but how can we be certain that your team can actually build a working vehicle? Have you considered the risks if this project fails publicly?" Colonel Traoré had expected this question and was prepared with a detailed response. "Minister, we propose a phased approach that minimizes risk while building confidence. The first phase would involve constructing a single prototype, using our own workshop facilities and existing budget allocations. Only after successful testing would we consider larger-scale production investments." General Sawadogo leaned forward and asked, "What about international certification and standards? Military vehicles must meet strict safety and performance requirements that are recognized internationally." Captain Kabore answered this question, explaining that they had researched international military standards and incorporated these requirements into their design specifications. They also planned to invite foreign military observers to participate in testing, ensuring transparency and credibility for their results. The questioning continued for over an hour, covering topics from spare parts logistics to potential export opportunities. Colonel Traoré and his team answered each question with detailed information and realistic assessments of challenges and solutions. As the formal presentation concluded, Minister Wende requested a private meeting with the senior military leadership to discuss the next steps. Colonel Traoré and his team waited anxiously in an adjacent conference room while the decision-makers deliberated. After what seemed like hours, General Sawadogo emerged and called them back into the main hall. His expression was serious but not discouraging. "Colonel Traoré, your team has presented a thorough and professional feasibility study. We have decided to authorize the next phase of this project." The room erupted in quiet applause from supportive officers, while Colonel Traoré felt a mixture of relief and renewed pressure. General Sawadogo continued, "You will receive authorization to construct a single prototype vehicle. The budget allocation will be 200 million CFA francs, and you will have 8 months to complete construction and initial testing." Defense Minister Wende added important conditions. This prototype must undergo rigorous testing, including live-fire exercises and explosive resistance trials. We will also arrange for evaluation by independent military experts. The vehicle must prove itself completely before any consideration of production expansion. The prototype phase would be far more challenging than the feasibility study. Colonel Traoré's team would need to transform their theoretical design into a working vehicle that could withstand the harsh realities of military service. They would also face intense scrutiny from skeptics who hoped the project would fail. Over the following weeks, The team established their manufacturing workspace in a converted warehouse on the outskirts of Ouagadougou. The facility was basic but functional, with concrete floors, high ceilings, and enough space to accommodate vehicle assembly. They installed welding equipment, machining tools, and lifting gear necessary for heavy fabrication work. Finding skilled workers proved to be easier than expected. Word about the project had spread through the technical community, attracting mechanics, welders, and metalworkers, who were excited about the opportunity to work on something truly innovative. Many of these craftsmen had years of experience maintaining and repairing military vehicles but had never been involved in original design and manufacturing. The first major milestone was completing the chassis assembly. Using components from a proven commercial truck platform, they modified and reinforced the frame to handle the additional weight and stresses of armor protection. This work required precise engineering calculations and careful welding to maintain structural integrity, while adding mounting points for armor panels and weapons. Systems. Sergeant Chief Compaoré supervised much of the hands-on fabrication work, ensuring that theoretical designs could actually be built using available tools and techniques. His practical experience proved invaluable in identifying potential problems before they became expensive mistakes. By March 2019, the basic chassis was complete and ready for the hull construction phase. This would be the most critical and challenging aspect of the entire project, requiring skills and precision that would determine whether the vehicle provided adequate protection for its occupants. The team worked long hours, often staying at the facility until well past midnight. The pressure was intense, but morale remained high as they watched their vision slowly taking physical form. Each completed component brought them closer to proving that Burkina Faso could indeed produce its own military equipment. However, they also faced growing skepticism from some quarters. Rumors circulated about cost overruns, technical problems, and doubts about the project's ultimate viability. Colonel Traoré knew that they would need to deliver exceptional results to silence the critics and secure support for continued development. September 2019 arrived with a mixture of excitement and tension throughout Burkina Faso's military establishment. The formal evaluation of the LX70 prototype was scheduled to begin on September 15th, exactly 1 year after Colonel Traoré had first presented his ambitious proposal. The timing felt symbolic to everyone involved in the project, representing a full cycle of development from concept to reality. The evaluation committee was impressive and intimidating in equal measure. General Sawadogo led the domestic assessment team, which included representatives from various military branches and technical specialists. The international observers included Colonel Jean-Pierre Dubois from the French military's Equipment Evaluation Division and Lieutenant Colonel Sarah Mitchell from the U.S. Army's Foreign Military Systems Assessment Unit. The evaluation would take place at the Camboinsin military training area, about 30 kilometers outside Ouagadougou. This facility provided the space and security necessary for comprehensive testing, including live fire exercises and explosive testing that would be crucial for verifying the vehicle's protective capabilities. Colonel Traoré's team had spent weeks preparing detailed documentation about every aspect of the vehicle's design and construction. Technical manuals, test results, cost analysis, and manufacturing procedures were compiled into professional presentations that would support their claims about the LX70's capabilities and potential. The first day of evaluation focused on static inspection and technical briefings. The international observers examined the vehicle's construction quality, armor configuration, and mechanical systems with the practiced eyes of experienced military engineers. They asked detailed questions about materials, manufacturing processes, and design decisions that revealed their deep expertise in armored vehicle technology. Colonel Dubois was particularly interested in the composite armor system that Dr. Ouedraogo had helped develop. He carefully examined the ceramic tile installation and backing materials, making notes and taking photographs with obvious professional interest. His questions were technical and precise, focusing on aspects of the design that demonstrated genuine understanding of armor effectiveness principles. Lieutenant Colonel Mitchell concentrated on the vehicle's electronic systems and human factors engineering. She evaluated the crew positions, visibility systems, and control layouts from the perspective of actual operational use. Her background included combat experience in Iraq and Afghanistan, giving her insights into the practical requirements that armored vehicles must meet in real battlefield conditions. The second day began with mobility testing. The LX70 was put through a series of increasingly challenging driving scenarios designed to evaluate its performance in various terrain conditions. The vehicle successfully navigated steep hills, deep sand, rocky outcroppings, and simulated urban environments. Its handling characteristics and mechanical reliability impressed even the skeptical observers. Major Ouedraogo demonstrated the vehicle's communication systems and battlefield management capabilities. The integrated electronics allowed the crew to maintain contact with command centers while providing real-time location data and tactical information. These systems worked flawlessly during the testing, showing that the team had successfully integrated complex military electronics with their locally manufactured platform. The most critical testing began on the third day with ballistic evaluation. This phase would determine whether the LX70's armor could actually protect its occupants against realistic threats. The testing protocol had been developed in consultation with the international observers to ensure that it met recognized standards. For military vehicle protection, the first test involved small arms fire from various angles and distances. AK-47 assault rifles, the most common weapon used by insurgents in the region, were fired at different sections of the vehicle's armor. The results were encouraging. The armor successfully stopped all rounds without any penetration. Into the crew compartment, more demanding tests followed, with heavy machine gun fire and armor-piercing ammunition. These weapons represented significant escalation in threat level and would challenge the armor system's effectiveness. The LX70 performed well, with only minor damage to outer armor layers and no penetration of the protective barrier. The ultimate test came with explosive devices designed to simulate improvised explosive devices and anti-tank mines. The vehicle was positioned over carefully measured explosive charges, while instrumented dummies occupied crew positions. The blast tests would reveal whether the hull design and armor configuration could protect occupants from the types of attacks that had killed so many soldiers in previous incidents. The first explosion sent a shockwave through the ground and filled the air with dust and debris. As the smoke cleared, the evaluation team approached the vehicle to assess damage and check instrument readings from the test dummies. The hull remained intact with no penetration, and the instrumentation showed that occupants would have survived the blast with minimal injury. Additional explosive tests confirmed the vehicle's mine-resistant capabilities. The V-shaped hull deflected blast forces away from the crew compartment, while the armor and structural design absorbed and distributed the impact energy effectively. These results exceeded the expectations of even the international observers, who had seen many vehicles fail similar tests. Colonel Dubois was particularly impressed by the simplicity and effectiveness of the design approach. During a break in testing, he commented to Colonel Traoré that many expensive imported vehicles had failed similar tests due to overly complex designs that created vulnerability points. The LX70's straightforward engineering had avoided these pitfalls while achieving superior protection levels. The final day of evaluation focused on maintenance procedures and manufacturing assessment. The international observers examined the workshop facilities, interviewed the craftsmen who had built the vehicle, and reviewed the cost estimates and production plans. This evaluation was crucial for determining whether the project could realistically expand beyond a single prototype. Lieutenant Colonel Mitchell spent considerable time talking with Sergeant Chief Compaoré about field maintenance requirements. His explanations of how the vehicle's design facilitated repairs using standard tools and locally available parts clearly impressed her. She noted that many sophisticated imported vehicles became useless in remote areas due to specialized maintenance requirements that could not be met by local mechanics. The manufacturing cost analysis was another area of significant interest. Captain Kabore presented detailed breakdowns showing how local production could reduce vehicle costs by approximately 40% compared to equivalent imported systems. The savings came not only from lower labor costs but also from reduced transportation, documentation, and intermediate dealer expenses. Dr. Ouedraogo's presentation on material sourcing and quality control impressed the evaluators with its scientific rigor and practical approach. The composite armor system could be manufactured using regionally available materials, reducing dependence on foreign suppliers while maintaining superior protection characteristics. As the formal evaluation concluded, Colonel Traoré felt cautiously optimistic about the results. The LX70 had performed well in all testing categories and had clearly impressed the international observers. However, the final assessment would depend on detailed analysis of all test data and careful consideration of the broader implications for Burkina Faso's military capabilities. The evaluation committee retreated to prepare their final report, while Colonel Traoré and his team waited anxiously for the verdict that would determine the future of their innovative project. The months of intensive work had culminated in this moment, and the stakes could not be higher for the future of indigenous military manufacturing in Burkina Faso. The results would be announced within a week, bringing either validation of their efforts or the disappointment of seeing their dreams of military self-sufficiency postponed indefinitely. Either outcome would mark the end of one phase of the project and the beginning of whatever challenges lay ahead.